All right, how to calculate a weighted standard distance with geographic data in R. All right, let's put together a quick little random pattern of points here. Okay, so if you remember, when we were talking about when we're talking about a weighted standard distance or a standard distance in general, we were talking about a circle centered on our mean center, which I'm gonna guess is probably about here. Remember, that's the mean longitude and the mean latitude. So here's our mean longitude and our mean latitude. That's the point in the center. Our standard distance is the radius of a circle that, when drawn around that center point, mean center point, contains about 68% of all of our data. Okay, so it's essentially the same thing as a standard deviation, but it's happening in 2 dimensions. Instead of just going up and down a number line, it's going up and down longitude and latitude, so it becomes a 2-dimensional measure. And it just incorporates a circle the size that contains 68% of our data, right? When we weight that, what we're saying is that points that have a higher value in the weighting scheme, whatever that may be, count for more. So let's say again that we have our mean center is somewhere here in the middle. And let's say then that those points that are close by, I'll draw circles around them indicating the size of their weights. The points that are close by have small weights, but the farther out we get, the bigger the weights become. Okay, so we have, well, this one would be really big too. This one would be quite large and quite large. Okay, so that we have weighted values on the outside. The result of that, the effect of that would be that these points on the outside, on the periphery of our distribution, would be pulling not only the mean center towards themselves, so the mean center would probably move a little bit in this direction to get closer to these bigger ones over here on the right, but it would also expand the size of our standard distance. So they're going to be pulling in all directions out towards the middle so that our standard distance would get bigger. Right? So it's still the same thing. It's still the radius of a circle, but now I didn't leave myself nearly enough room here. So it still contains, now instead of containing just 68% of our data points, it contains 68% of the weight of the data. Okay? So it's the same thing as a standard distance, but by weighting it, it pulls it in the direction either in or out, right? If our heavier points were in the middle, then it would be pulling the standard distance would be smaller because it would be pulled in towards the center. But if all the weighted values are on the outside, it would pull that outward. All right, let's learn how to calculate a weighted standard distance using R. So we've got quite a few lines here. Here, of course, I'm cleaning my workspace off so that I'm not interrupted by anything that I may have done in a previous session. I'm opening the Map Tools library. I'm using the random normal generator to create 20 numbers with a mean of 10 and a standard deviation of 2, and then formatting that as a column or as a matrix with 2 columns, and then dumping that into the spatial points pattern. So here I'm creating my dummy spatial points arrangement. This is going to be a weighted standard distance. So here I'm creating my list, my weights objects. These are that any points that are farther away from the mean center will weigh more. So my weighted standard distance should be greater than my normal standard distance. And then here I'm opening up just the library or the package GIS tools and creating a choropleth map of that data so that we can look at the generated points. So here is the pattern that we have. Points that are closer to the middle weigh less than points that are farther out, right? These lines here, all I'm doing is calculating the mean center, not a weighted mean center, but the standard mean center, and then calculating a standard distance, not a weighted standard distance, and plotting them so that we can see what they look like before they are weighted. So this black dot right here is my mean center. That's just the mean longitude and the mean latitude. And this circle is my standard distance, an unweighted standard distance, such that 68% of my data points should fall within a circle with the radius of my standard distance centered on my mean center. Okay, so this is what the data look like before they are weighted. A When we weight the mean center and turn it into a weighted mean center, this blue dot is now my weighted mean center. So these points that are darker red weigh more, they exert more influence, and they are pulling that mean center out towards the more heavily weighted points, and so it moves from here, my unweighted mean center, over here to my weighted mean center. So it's moving a little bit to the northeast. So here's how we calculate a weighted standard distance. The equation for a weighted standard distance is this. It is exactly like the equation for the standard distance with the addition of the weights right here, which get multiplied by the squared deviations in the longitude here and the latitude over here. That gets multiplied by those squared deviations before they're summed, and then of course we divide by the weight of the sum of our weights again, right? The only other thing to remember when you're calculating a weighted standard distance is that the mean longitude and the mean latitude are weighted distances now, right? Weighted by that same weight, whatever our f is. So that's the equation. So the first thing we need to do is calculate these deviations, which we will do in a single command for the longitude and the latitude, square them, multiply them by the weights, and then sum them up, right? So calculating the numerator there. So that is what's happening right here. Here is our function. It's a temporary function, so I'm just calling it temporary. We're going to supply here the longitude and the latitude. X will be both, because we're going to call this function for both of them, and we're supplying our weights. So here we're calculating, here is our x minus the weighted mean. We're squaring it, multiplying it by the weights, and then summing it up. Okay, so this is the numerator of that equation, or will be when we run it. Here we're running it, so I'm just going to call that y, but when I apply this function, temp, to my coordinates, which I have extracted up here using the coordinates command, right, when I apply that, it will calculate out here the two values that must be added together in our numerator, and I'm supplying f as my weighting variable here to my object w, which I have defined here in this function. Okay? So when I run this, these are the weighted summed deviations of the longitude from its mean, its weighted mean, and these are the summed squared weighted deviations in the latitude right here. So we have those both now saved as y. So for the rest of the function, or the rest of the equation, all I do is sum those up in the numerator, divide them by the sum of the weights, and find their square root, and that is the weighted standard distance. So if I run that, I see that my weighted standard distance is 3.48. Before, the unweighted standard distance was 3.06, so it did get a little bit bigger as our more external points pulled the standard distance outward. And I can map that using the symbols command like we've done here before. So I'm putting in the longitude of the weighted mean center and the latitude of the weighted mean center because they have to be centered on that point. I want to draw a circle whose radius is equal to the weighted standard distance, and I've set inches to false and add to true so that it shows up on my map in the right units. And I've asked that the circle be drawn in blue so that it matches my weighted mean center. So we can see that it's shifted because it's now centered on a new mean center, and it has grown because the more heavily weighted items on the outside of my distribution pulled the standard distance out. Okay, so there's a lot of lines of scripts here, but right here, those three lines are how you calculate the weighted standard distance, and this is how you display it on your plot.